Dear students, in this session we are going to see about electric potential at any point due to electric dipole. So are you remember what is electric dipole? Yes, the two equal and opposite charges, there is a positive and negative charges separated by a small distance. We always mention the small distance as a. So immediately we should remember that what is the dipole moment? P is equal to the product of a charge into the distance between them. Yes, very good. You should keep these are all the things whenever we talk about the electric dipole. So we already derived the expression for electric field due to a 1 point charge. If there is a 1 charge means, so we have the equation V is equal to 1 by 4 pi epsilon naught Q by R. R is the distance between the charge and the particular point. Now we are going to derive the expression for electric dipole, electric potential. Yes, this picture clearly shows that there is an electric dipole negative charge and positive charge separated by a distance 2a. Here it's a. This is a center point O. So we never take the point along the axial line or along the equatorial line as similar to the electric field of the electric dipole. Now we are taking a point at the cross section, that is in this angle, at a particular angle. This is a point P. Now we are going to determine the electric potential at any point at a point P due to this electric dipole. Evidently, in this electric dipole, we have two charges. One charge is a minus Q, another charge is a plus Q. So we have the electric potential due to this point charge also, point plus Q charge also, and this point minus Q also. So by substituting the equations, the electric potential due to this point plus Q charge is 1 by 4 pi epsilon naught plus Q by R2. So R2 is a distance between the positive charge and the point P, and plus the what is electric potential due to the negative charge? 1 by 4 pi epsilon naught minus Q by R1. R1 is the distance between negative charge and the point P. So the sum of the electric potential due to the negative charge and the positive charge is a total electric potential of this electric dipole. Let's we go to the simplification. So 1 by 4 pi epsilon naught Q, everything will be common outside. So we have only 1 by R2 minus 1 by R1. So R2 is a distance between the plus charge and the point P, and R1 is a distance between the negative charge and the point P. So by taking the LCM, R1 minus R2, and we have to multiply these two things in the denominator, R1 into R2. This is the equation 1. Now we are going to determine what is the value of R1 minus R2 and R1 into R2. By seeing the diagram itself, so from this point to this point the distance is R2. So if you draw the normal line from positive charge to R1, so this distance is R2. This distance is R2. This total distance is R1. So this is R2. This total distance is R1. So this distance must be R1 minus R2. Again I will explain to you. This distance is R2 because this is these two are in the same distance. What is the whole distance from negative charge to point B? That is a R1. So the whole distance minus this distance is R1 minus R2. That is we are mentioned here R1 minus R2. Now you see that cos theta. So why we will put the cos theta in order to find the R1 minus R2. So this is an angle theta. This is a 90 degree. Hence this angle is also become theta. So cos theta is adjacent side by hypotenuse. So the adjacent side is 2a and hypotenuse is R1 minus R2. So we can write that cos theta which is equal to adjacent side by hypotenuse R1 minus R2 by 2a. R1 minus R2 is equal to 2a into cos theta. Also here we are assume approximately taken that this R1 distance and R2 distance are only slightly differ. So approximately R1 and R2 are equal. Hence we put R. Students may arise the question, sir, in previous step you put that R1 minus R2 is equal to 2a cos theta. But in the next step itself you say that R1 and R2 are equal. That we put R. Substitute R minus R, we get 0 only, sir. Yes. for the mathematical calculation, for simplification, we are doing the approximation method. For in order to find R1 into R2, we have to go this approximation method. So R1 minus R2 is 2a cos theta, and R1 into R2 is simply R squared. So that is we are going to substitute here. V is equal to Q by 4 pi epsilon naught into R1. Instead of R1 minus R2, we have to put 2a cos theta. So in denominator, in this equation, we have R1 into R2. So R1 is R, R2 is R into R squared. So we get R squared. Already we know that Q into 2a, 1 by 4 pi epsilon naught, Q into 2a is, what is the Q into 2a? Yes, it is a electric dipole moment P. P is equal to Q into 2a cos theta. So this is the expression for electric potential at any point due to electric dipole. So whenever we substitute, when the angle theta is equal to 0 degree, when the angle cos theta is equal to 0 degree, so what we will get? The axial line. So now we go to the diagram. So the point P is at this point. So this is the axial point. So point is along the axis of this electric dipole horizontal. So what is the electric potential at this point due to the electric dipole? Means merely you have to substitute theta is equal to 0 degree. How is the theta is equal to 0 degree? You see that this is an angle. Okay, this is an angle made by this line R. So if this angle is become like this, then only it is an axial line. So the angle will become 0. So only we substitute for cos theta 0, cos 0 1. Simply we get only 1 by 4 pi epsilon naught P by R squared. When the point P, so the first point we will see that this point P will comes to the horizontal point, that is the angle becomes 0. The next one is if the point B become vertically normal, that is a 90 degree. The angle is 90 degree with the dipole. So the point P is at this point. We have to substitute for cos theta 90 degree. What is the cos 90 degree? So the cos 90 degree value is 0. So the electric potential due to the equatorial point is 0. So similar to the electric field for the electric dipole, so we have the axial point and equatorial point. So in previous unit we have the separate derivation for axial point and equatorial point. So this is a simple derivation with a single question. One question itself we have able to derive the expression for axial point as well as the equatorial point. Yes, instead of the two charges, if we have the system of charges, if there is a n number of charges, as usual there is the charges q1, q2, q3 and n number of the charges, qn number of the charges. We are going to find the electric dipole at this point P, this point. So the distance from the first charge to the point P is r1, second charge is r2, third charge is R3. If there is a n number of the charges, nth charge is Rn. So the what is electric potential at this point P due to this all individual charges is we have to calculate the electric potential of Q1, Q2, Q3 up to for the Qn. All the electric potential, individual electric potentials has to be sum up. That is we are written here. V is equal to V1 plus V2 plus V3 plus etc. up to Vn. By substituting this V1, V2, V3, we get the full equation. That is a complete equation. So what is the potential formula? KQ by R. So Q means that is the first charge Q1. What is the distance between the first charge and the point B? That is the R1. KQ1 by R1 plus KQ2 by R2 plus KQ3 by R3 for the up to nth charge. So simply we can write that in general V is equal to 1 by 4 pi. Instead of K we substitute 1 by 4 pi epsilon naught. The summation of I is equal to 1 to n Qi Ri. That means first you have to put instead of I 1 that is a Q1 R1, summation denotes plus. That is the plus comes. Again you have to substitute I is equal to 2 Q2 R2. So Q2 R2, then the summation denotes plus. Likewise we have to. So this entire big equation can be simplified in general form. We can write in this form also. So this is the equation for electric potential for the system of charges.